I'm James. I've been a member of the Systems Committee for 6 years and a member of the group responsible for coding the archive, which is called Accessibility, Design and Technology, or AD&T for short, for 4 years. My professional experience is in high throughput computing, which means that I have some experience in systems at scale, and that is useful because the archive has an average of over 270 page views a second. If something goes wrong with the archive, I am the most likely person to be woken up in the middle of the night. This is not heroic. Each time is a failure. We try and design systems so that various components can fail without the users of the service noticing. In this case, the day before, we had to fix an issue caused by the number of records which store all our users' reading history. We had to change the index size from 4 bytes to 8 bytes. This made the database bigger by about 3%. The next day we had an issue. We had a number of servers which generate pages for the archive, and 3 of them hit the same type of failure at once. The 3 machines ran out of memory. All those extra 4 bytes add up. We used spare memory on the servers as a cache, and when those 3 machines failed, we lost that cache and the processes generating the pages, which is a large enough part of our estate that the archive stopped responding on a Sunday night, our busiest time. That night, I was out being a taxi driver for my eldest son, collecting him from a college trip where they'd come second in the UK Students' Robotics competition, so fixing things took a little bit longer than they normally do. The Organisation for Transformative Works, the org, is one of the core reasons for the stability of the archive. It's an American not-for-profit founded in 2007 with the goal of legitimising fanworks. The org and its projects are fan-run, and the vast majority of the fans involved are women. The org was set up in a time where there's a worry about companies monetising fan content. Because the hosting companies relied on advertising, it was fairly easy to convince them to destroy content which some people believed was abhorrent. One of the main tenets is therefore to own the servers, to ensure that the archive is a safe place for content creators. Wild tags can help ensure that the readers see the works they want or being able to avoid unwanted content. As the terms of service say, you understand that by using the archive may expose you to material that is offensive, triggering, erroneous, sexually explicit, indecent, blasphemous, objectionable, grammatically incorrect, or badly spelled, and, if you're lucky, all in the same work. The first work on the archive was posted on the 13th of September 2008. The archive entered open beta on the 14th of November 2009. My account was created in September 2010. There are a number of committees that provide the infrastructure for the org. Communications creates the annual report, creates some news posts, and runs some social media accounts. Think public relations. Development and membership runs the 2 annual fundraisers, communicating with members and potential donors. Elections runs the tea process for the board of directors. In the past, we have had too many years when we have not had enough people running for the board, but that has not been an issue in the last 3 years. Finance are responsible for accounting, budgeting, payments, and tax filings. Strategic planning works on the big picture strategic questions and vision. Systems is one of the 2 committees I am a member of. We are responsible for specifying and procuring the servers that the org has, and for installing both the operating systems and the software systems, for example, the database that the archive uses and the software that is behind Transformative Works and Cultures, the Open Journal system. We run at least 3 different types of database. We run mail servers, web servers, etc. The board of directors is responsible for setting high-level goals an org-wide policy, financial well-being, following federal, state and our own laws. It provides support and guidance to other committees. Translation is the committee that translates many of the news posts on the archive and the FAQ entries. They also supply translation for support tickets raised in languages other than English. In time, we will get to translating the archive interface. Volunteers and recruiting. Manage new starters and leavers and ensure that the right people have access to the right tools. While there are many tasks that Volcom does not do that a HR department does, they're the nearest the org has to a HR department. Webs, responsible for maintenance of the org's website, transformativeworks.org, elections and open doors. Transformative Works and Cultures is a peer-reviewed, academic, public access journal which publishes articles about transformative works, media studies and the fan community. Legal provides guidance whenever needed for internal legal questions. The legal committee is dedicated to helping fans who have questions about their own fan works and to engage in public advocacy on legal issues likely to impact fans and their fan works. Fan Law, a wiki about fandom history and fan culture, written by fans. Abuse field the complaints that come in about content uploaded to the archive, whether that is works or comments. Accessibility Design and Technology. AD&T is the second committee I am a member of. It coordinates design and development for the archive. This means that we maintain and update the archive code and are the first in line of fire when emergencies happen, and generally make decisions regarding what new features are coming next and what needs prioritisation and fixing on the archive from the technical side. Archive documentation writes, edits and revises archive documentation, including FAQ and tutorials. Open Doors is dedicated to preserving fan works for the future. In practice, this involves importing a large number of works from fragile websites or database backups to new collections created on the archive. Support helps resolve technical problems experienced by users and passes on users' feedback about the archive to coders, testers and tag wranglers. Tag wrangling. Work within the archive to ensure that the varied forms of user-generated tags are sorted and filterable without changing any of the specific tags the user chooses, so that archive users have an easier time finding the type of content they are looking for at any given time. There's a great difference in how you design a system to support a small number of users and how you design a system for a much larger number of users. According to free comparison services, the archive is one of the top 400 most popular websites in the world. Back in 2012, we doubled the number of page views over the year from 18 million to 38 million pages. However, the percentage increase has been slowing, and this year, last week, we had only risen by 36 million page views compared to an increase the year before of 38 million. I guess that the first month with over 1 billion pages a month will be either December 2018 or January 2019. The following images come from the system we use to help us find the slow parts of code and help us find parts of the archive that are causing issues. This page shows how many users we have and how much downtime we've had. The tool marks the site down, both when it is truly down and when it is unavailable from a number of probing points. We can see what proportion of time is taken up by each of the processes of rendering a page. Here we can see that as all the servers in the archive are located in a single location, that network time is significant. Document object model processing is the time between the first bit of HTML being received by the web browser and the last bit of HTML. By looking at the displays, we can see where the issue is. For about 5 minutes, we can see there was a doubling of how long it took to deliver a page to the user. Looking at the applications view, we can see that most of the time is spent queuing, which means there were not enough processes available to generate the page, which was caused by each page taking a lot longer to generate. Now, removing the queuing, we can see that the delay was in Web External, which for us means Elasticsearch, which is used to power our tagging system. Just to show that without Web External, everything looks normal, so we would look at the logs for Elasticsearch to see what the issue was. When doing maintenance, I try not to think about how many people are affected by the work I am doing. While most of the users are on mobile, we don't have the resources to dedicate to app development. While we do want to write a stable API for the archive, this is not something I see happening in the immediate future. It is worth noting that if an unofficial app requests your login and password, you are trusting the app with both your reading history and the power to comment and kudos, create and delete works. Even though we just serve text, we serve about half a petabyte a year. When we do eventually start serving media, video and audio and pictures, we will need significantly more bandwidth, as our current capacity is only equivalent to 60 streams. We currently have servers in 3 data centers. I'm going to call the sites Alpha, Amiga and Landing Strip 1. The org has a policy of not naming suppliers generally. We get enough emails through our ISP, either of the cease and desist nature or people trying to convince our ISP that we are evil. We use router systems at all 3 sites as VPN servers because they provide a cost-effective solution. At Landing Strip 1 and Amiga, router systems are also used as firewalls. At our main site, Alpha, we use the router system as only an inter-site VPN server and a firewall, so that the FanWorks server is isolated from the other machines, while we use a pair of pfSense firewalls as our main ingress, and our Brocade switches as the main Layer 3 router. We have started to migrate our out-of-band management to a separate VLAN. Currently, our front-end machines have an inbound and outbound network. I would like to do this later for our Galera cluster. The network in Amiga is particularly simple. The VPN just connecting to Alpha. The network at Landing Strip 1 is slightly more complex as we host developer machines, access to which is given out relatively freely, and we need to ensure that access to these systems does not give additional privileges. Amiga is a relatively new data center for us, and we've had it for about a couple of years. It is mainly used as a DNS server and a MySQL secondary server for the archive and FanLore. It does use obsolete hardware that has some use still left in it. This year I hope to move more recent equipment from Alpha to Amiga. Landing Strip 1 has a large number of virtual machines. The hardware is over 4 years old, and we plan on moving it over to a NAS role and buying new servers to take over the compute component. For just over 2 years, we've had a single rack in Alpha. This does make things more easy for us, When we were spread over multiple racks, I was often worried that strange problems were caused by low bandwidth between ISP switches in each of the different racks in which our VLAN was hosted. This is the specifics of the hardware we're currently using. If and when we get to the hosting media, I'm expecting to have to add additional 25 gigabit per second switches and update firewalls and front-end machines. This is an example of our current low-power machine. We use the NVMe as the var partition, as while this system is only relaying email from the systems that generate the mail, we do send over 500,000 emails a day, and this does cause a lot of I/O. We do have 2 servers running a large number of VMs, including machines for FanLore and the journal. We also use the servers to provide machines for non-time critical features of the archive, such as generating downloads and serving pages to web spiders such as Google. We have our own GitLab instance. This is a Git server with a web interface. Git is a source control system which we use both to hold copies of the archive source when we want to collaborate on security fixes that we don't want to be public before they are deployed, and for both Ansible and CFEngine. CFEngine is the infrastructure framework that we have been using since 2012. Before this, all changes on the server we had, all 3 of them, were done entirely by hand. I chose CFEngine at the time as it is the system I used at work. It is not the most pleasant system and has some sharp corners, but it has meant that deploying new servers is relatively pain-free. Ansible is a much more modern system, and I'm not the only member of systems who can use it. We're slowly migrating functionality out of CFEngine and moving it to Ansible. Fray is the system we use to install the operating system on our servers. It boots the system from the network and installs Debian and CFEngine. From there, CFEngine runs multiple times and the server should be usable, assuming it's running a role we have already configuration for. We try and ensure that any system where failure would take the archive offline is replicated and hopefully running active. After the firewalls come the web front end, whose task is to do SSL termination, serving of static assets such as CSS and images, and some full-page caching. More interestingly, it sends different types of requests to different sets of application servers. For example, we use slower VMs for spiders and downloads. We have special pool of application servers put aside for writes, such as word creation, comment creation, and kudos giving, so these are prioritized. Redis is a NoSQL database. We use Redis to hold non-relational data that we want to access quickly, for example, autocomplete. We also use Redis to temporarily store information before it is written out to MySQL. An example of this is the reading history. Our MySQL servers couldn't support 15 million writes a day to a single table just to support the reading history. So we temporarily store the information in Redis and write it to MySQL in batches of 1,000 records every 15 minutes. We also use Rescue, which allows jobs to be run asynchronously. That is, a page that you visit may cause a process which could take several seconds or minutes to run, which makes it impractical to have a web page wait for you. In this case, a job is created using Rescue and run later. Redis is used to provide the Rescue service. As Redis is a single-threaded system, we run multiple Redis processes to make it less likely that we overwhelm a single process. We have Redis instances for storing kudos, rescue, rollout. This would allow us to have features in test for a subset of users, and a general Redis database. It is worth noting that Redis is not replicated with failover, as the Jefferson report on Sentinel was too worrying. If we plan maintenance on Redis, we take the archive offline to do it. We've recently moved Redis from an old MySQL server, which was only serving Redis, to a new MySQL server in our cluster, so we could redeploy the old server as an application server. If Redis stops, the number of errors users see spikes tremendously. Elasticsearch is what we use to power our tagging. While all the state of the archive is canonically stored in MySQL, we use Elasticsearch often to display the data. Unpleasant things happen if the data becomes out of sync. For example, your work may not turn up in searches or may not turn up on the tag page. The version of Elasticsearch we are using is ancient for a software project. It's coming up to its 4th birthday. The reason it hasn't been upgraded is that the gem or library we use to access it is no longer supported, and changing the core code around this area is scary. We have got an agreement for a contracting company that we have used to refactor this code into shape, using a modern gen and a much more recent version of Elasticsearch. For Jefferson, this is pretty positive. However, for us, we often get complaints when works are missing from a tag or fandom listing. We don't use Elasticsearch as a canonical data source, but we don't routinely rebuild indexes. However, documents do get a re-index as a side effect of some processes. Things will get better when we upgrade to a more modern gem than the current version of Elasticsearch. We have been using Percona ExtraDB cluster, Galera cluster, since October 2014. This has significantly reduced the amount of downtime we have had due to database issues because 3 machines can handle a lot more load than a single machine. Not 3 times the load though. If we need to take down a server from either a hardware fault or a software update, then we have 2 other machines which we can keep the site running, while the 3rd machine is being worked on. We have 3 servers in our MySQL cluster, and these are the most expensive machines we buy. I have a tendency not to buy all 3 machines at the same time. By buying 2 servers one year, a single one the next, we can smooth the cost of the systems out. Our old database servers generally get recycled into application servers, running the archive code itself. The oldest database server was bought in 2015, and I expect to retire it from database work in the next couple of months. It's worth noting 2 things here. These machines have plenty of RAM and very fast disk. The MySQL database process sits at 465 GB of RAM on these machines, and the whole of the MySQL data area takes 449 GB of disk space, 407 of which is just for the archive. Fanworks, for example, is 10 GB. The NVMe runs at about 1.2 GB per second, which is fairly fast. These are machines we bought last year. They look very similar to the years before's. However, the RAM was increased by 50% and the CPU is a family later. With Galera Cluster, you can apply writes to any node in the cluster. Using a rather complex system, it can ensure that the same data is written to all the nodes in the cluster. The idea is that if there is a conflict, a certification failure, then all nodes will agree on that conflict. If you ensure that all the data is written to a single node, then there is less opportunity for certification failures. We run an instance of MaxScale on all our MySQL clients, set to steer all the queries that are writes to a single server, generally the eldest. This reduces the likelihood of certification failures and means that the system dealing with the important writes, kudos, comments and works, is not being bothered by the read workload. Having a MaxScale instance on each client is not completely usual. We do this to move complexity to a place where it is easily understood, to me at least. Traditionally, you would have a floating IP address which migrates around the 3 servers controlled by Pacemaker. This, to me, is a complex system. Given that we have to have a method of installing and configuring software packages on each machine, CF Engine at present, Ansible in the future, I find it simpler to use that mechanism and have the MySQL client on each machine talk to its local instance of MaxScale. We're currently using MySQL 5.6. I'm considering if we should migrate to MySQL 5.7 or MariaDB 10. The amount of data we're storing just keeps on increasing. Since I started writing this talk in January, the amount of disk space used has gone up by about 10%. We already have 3 copies of the database on 3 separate machines in our data center. However, we use MySQL replication to ensure we have copies in Amiga and Landing Strip 1. This means that if there was a zombie apocalypse that only affected Alpha, then we would still have a replica off-site. It is worth noting that the system in Amiga is so old it can't keep up with the I/O load of replicating the information, and it slowly falls behind the other systems until I have to reinitialize the replica by hand. At this point, it is about 48 days behind the main system, which can be useful for abuse, for example. We use Percona Extra Backup to create online backups of our MySQL databases. We create weekly but full backups for the archive. These are created on one of our main servers and each of our replicas. From that backup, we could use MySQL binary logs to roll forward to any later time if there was an emergency. We have a number of machines running as application servers bought over a few years. The first 2 machines were bought in 2012 and are expected to move to Amiga in a couple of months so they can give a few more years service before they stop being useful. The set of 4 machines is a Supermicro Fat Twin, that is 4 servers in 2U. These were bought in 2014 and are becoming a bit old. The last machine was an old database server bought in 2014. In the next year, I expect us to purchase a new database server, allowing an Intel server with 55 threads to be used as an application server. I also plan on buying a new application server, I suspect an AMD EPYC 7551 with 128 threads. The 3 machines marked as asynchronous workers do the work such as sending email to users, matching for exchanges, and the inner workings of the tag wrangler. Here we're going to trace out the path of a request and how it is processed. After the client has done all of its DNS resolution and stuff, it will send a request to one of the IP addresses of our firewall pair. Next, the packet has to pass through the firewall rules. Now the packet is passed to an instance of HA proxy running on the firewall itself. This instance of a HA proxy is only used to load balance and allow us to take front ends in and out of service. We are now on the front ends. Nginx is used as the front end web server, and among its tasks are access control. The first stanza here is an example of blocking a client based on an arbitrary fact about a client, while the second stanza is denying access to clients based on IP addresses. In this case, the ISP advertises dubious hosting and was being used by a group who are proxying the archive and inserting adverts into the pages. These lists should be cleared periodically as IP address assignments do change over time. Route to the request. Here are some examples where the URL determines how long the page can take to generate. Note the tries file line. Here we see that if a file name matches the URL, then the file is sent. We then check the existence of maintenance.html. If that file exists, we return the page. When we want to take the site down, we move the file no maintenance.html to maintenance.html and wait a minute for the file system cache to flush. Then all requests will get the sad archive page, and we can do our work happy that no users can make requests. There could be rescue workers or cron jobs still around, so if there needs to be no changes, then these need fixing as well. Compression and SSL termination. These are pretty standard stanzas. We compress everything that is not an image, as these are pre-compressed. We get about 2/3 compression, so that currently our maximum line rate is 200 megabits a second. It would otherwise be about 500 megabits a second. We do support HTTPS for the archive. There are a number of places where we do drop down to HTTP, although we do have a pull request in to fix this. This is mostly a standard stanza, however the SSL cipher lines does need to be updated periodically. I generally use SSL Labs Quality Checker every so often to see if there needs to be any changes. Caches content. While we are updating Rails and changing our user authentication gem from auth logic to devise, we do a lot less page caching than we have done in the past. We used to use Squid for full page caching. However, given it is possible to do this in Nginx, we use Nginx caching for the archive. Fanlaw, for example, still uses Squid, as MediaWiki can communicate with Squid for cache invalidation. At present, we're only using Nginx caching for autocomplete. URL rewriting. We have three kinds of examples here. We have a number of domains that resolve to the archive, and we ensure that URL is changed to archiveofourown.org. Here we support old URLs for FAQ items which have changed over time. The last example is part of the configuration that is used for clients we have decided are web spiders. Here we ensure that URL has the flag needed so that the spider is not asked if it wants to see an adult work. Google PageSpeed is a module available for both Apache and Nginx. It does a number of rather, to me, complex operations. For example, taking an image such as the logo in the top left-hand corner of the archive pages and changing it to a data statement in the HTML, or taking CSS files and either inlining them or combining them together. Nginx will talk to a back-end instance of HAProxy. The two obvious reasons for using a HAProxy on the back end of the free version of Nginx are the web display seen here, and it is easy to programmatically take servers out of the load balance, which is useful when deploying new versions of the archive. We use God as a process manager, that is, its task is to start processes and ensure they continue to run. Unicorn is the web server that runs on each of the application servers. We've been using Unicorn since at least 2010, so while other options are available, we see no need to change. The archive is a Ruby on Rails application. Rails has a philosophy of convention over configuration, which means that there is usually a natural way to do things in Rails. The model holds the data and the behavior. The views are the representation of the data that the user sees, and the controller takes input from the user and updates the data using the model and prepares the data for the view. Active record is the component which is used to persist objects, data, while allowing programmers to use natural to programmers forms. For example, here I look up my account and set the number of failed login attempts to 0. Then I look up how many kudos and comments I have left, and how many works I have read logged in. Then I look up how much guest kudos has been left from our IP address. Here we see some code associated with storing readings. Update or create checks that the user is logged in and has their history enabled, and that they are not the author of the work, then creates an entry in Redis that will later be stored in MySQL, while marked read later creates the entry in MySQL immediately. This is part of the controller for readings. Before anything is called, we check that the user is logged in, that they own the data they're trying to access, that they have history enabled, and then we load that data for the user. For the index page, we then load up the data that the view is going to use. This is part of the view. Here we go through each of the readings and render a blur for each reading. This shows that each application server uses a local instance of HAProxy for reliability and to have local queuing where it's needed. This is a very quick overview of the development process. We have an issue tracker which is used to both log faults and features. It's worth noting that both bugs and features can take a long time before anyone starts work on the issue. For example, this issue was created over 5 years ago. I've done the work to migrate admin users, for example, but we still have to complete the work for standard users. This is a complex issue which involves changing the library we use for authentication and authorization to a better supported and more standard library. At some point, a developer will do the work and add the appropriate tests for the new code, and all the automated tests will succeed. This is Travis, our primary continuous integration system. The developer now believes their code is good and fit to be merged into the archive's code. The code is now peer-reviewed by the other coders in the group, and a member of AD&T can approve or request changes to the pull request, the changes that the coder wishes to make. AD&T meet weekly, and among the things discussed is which of the open pull requests which are ready to be merged will go into the next release. The decision is based on site integrity, is it a security or an important performance fix, requests from support, abuse, open doors or legal to help them in their work. Is it a feature that we believe our users would really appreciate? After a release has been deployed and we're happy that no emergency fixes are likely to be required, we will merge the next set of changes to the master branch on GitHub. This causes our second continuous integration test system, CodeShip, to start, and each change will be tested again. At the end of the test, CodeShip will deploy the new code to our staging servers automatically. Our QA quality assurance team now tests each issue by hand, updating the issue tracker. If there are problems, then the developer, usually the original one, will try and write a fix and make a new pull request. If no one can easily fix the issue, then the feature or bug fix will be reverted. The change will be undone. Once all the issues have been verified, then the new release is deployed to beta, the archive. Any changes to the database tables will be done in advance of the deployment. Given the size of the database, we have some plans to make migrations less disruptive. Changes to the CSS are done by hand at the end of the deploy. And finally, there are a large number of systems that the archive relies upon. I would like to thank everyone who has created a work for the site. And we do get plenty of thanks sent to support, which is collected by Anne Lee, who records it and ensures that the coders know how much they are appreciated. My colleagues in systems, Amanda, Els, Karen, Matthew, Pucklin, Seamus, Tom. And the members of AD&T, Ariana, Bingaling, Els, Engel, Lady Oscar, Mumble, Naomi, Sarkin, Scott and Katie.